Hi, this is Mrs. Rodriguez with Factoring Intro Lesson. Module 3, Warm Up 2, CAS practice question. David uses a half a cup of apple juice for every 1/4 cup of cranberry juice to make a fruit drink. What is the number of cups of apple juice David uses for 1 cup of cranberry juice? Well, if a half a cup of cranberry or apple juice is 1/4 cup cranberry juice, let's go ahead and write that down. If a half a cup of apple equals 1/4 cup cran, right? And now he's going to do 1 cup of cranberry. Well, I know that if I started with 1/4 of a cup of cranberry juice, 1 cup would be 4 times that, right? Because 1/4 times 4 equals 1. So if I have to multiply the cranberry juice by 4, then I have to multiply the half a cup of apple juice by 4. So it'd be 1/2 times 4. A couple of ways you could do that. You could multiply fractions. You could have 1/2 times 4/1, and you get 4/2. 4 divided by 2 is 2 cups. You could draw a picture. So there's different ways you can do that. You can draw 2 circles, and we have half a cup, and we have 4 of them. So half a cup and a half a cup would be 1 cup. Another half and another half would be 2 cups. However you want to do it, whether you want to do it, if you want to calculate it, draw a picture, whatever makes you feel better. All right, so moving on to today's lesson. Today's lesson is an introduction to factoring. Okay, let's take a look at example 1. Example 1A, use the model to answer the following questions. How many 5s are in the model? Well, let's see, we have 1 5 here and 1 5 here, so there are 2 5s. How many 3s are there? There are 1, 2 3s. So we have 2 3s. What does the expression represent in words? So in words, the expression represents the sum of 2 groups of 5 and 2 groups of 3. Now, you need to remember that sum means addition. So this is 5 and 5, 2 5s, and they're adding to those 2 3s. So it's the addition of 2 groups of 5s and 2 groups of 3. Okay? What expression could we write to represent this model? Well, if we have 2 5s, we could write 2 times 5 plus, there's 2 3s, so 2 times 3. Part B, use the new model and the previous model to answer the next set of questions. How many 5s are in the model? Well, once again, we have 2 5s. How many 3s are in the model? Once again, we have 2 3s. What does the expression represent in words? So you'll notice in the first model, it was 2 times 5 plus 2 times 3. In this case, we have 5 plus 3 and 5 plus 3. So in words, I would say that this is 2 groups of the sum, right? 2 groups where we're adding them together of 5 and 3. What expression could we write to represent this model? Well, we have 5 plus 3 plus 5 plus 3, or we could just simply write 2 times 5 plus 3. Because remember, this is one group, this is another group, and we're adding them together. Okay? All right, moving on. Is the model in part A equivalent to the model in part B? So first, we need to remember what equivalent means. And equivalent means equal. Okay? Equivalent means equal. So they're asking, is the 2 times 5 plus 2 times 5, is that equal, okay, is that equal to the 2 times 5 plus 3 that we saw in part B? So what we need to look at is whether or not if we multiply them out, will we get the same answer. So for the first problem, we have 2 times 5 and we get 10 plus 2 times 5, which is 10. And if you add those together, we get 20. So the left-hand side equals 20. Uh-oh, I messed that up. Sorry, guys. This was actually not 2 times 5. It was 2 times 3. All right, so that's going to change things. Oopsie. So that's going to be 2 times 3, and 2 times 3 is 6, and 6 plus 10 is 16. All right. So we have 16, and is that equal to the other side? Well, we have 2 times 5 plus 3. 5 plus 3 is 8. 2 times 8 is 16, so yes. Okay, yes. Now the part we're supposed to see is, for the relationship as what's happening on either side, is on the left-hand side, two is being multiplied by 5, and then by 3 before adding the products together. On the right hand side, the 5 and 3 are added first and then multiplied by 2. Okay, so on the left-hand side, 2 is being multiplied by 5 and then by 3 before adding the products together. On the right-hand side, the 5 and the 3 are added first and then multiplied. So what you were supposed to recognize is, yes, they're the same thing. The only difference is here, the 2 multiplied with the 5 and the 3 separately, and over here, we factored out the 2 and the 5 and the 3 are inside. But remember, when you use the distributive property, that 2 will multiply first with the 5 and then with the 3, right? If we were looking at variables. So the biggest take I want you to get from this is that we have something called a common factor. And a common factor is a factor that both parts have in common. In this case, it's the 2. Okay? And on the right-hand side, all they did was factor out the common factor. Okay? They factored out so 2 is the common factor, the number that both 5 and 3 multiply with, and they just removed that 2 and put it on the outside, right? They factored it out and left the 5 and the 3 on the inside. In grade 5 and in module 2 of this year, you've used similar reasoning to solve problems. What is the name of the property that is used to say that 2 times 5 plus 3 is the same as 2 times 5 plus 2 times 3? So whenever we factor out a common factor, when we multiply it back in, it's called the distributive property. All right, let's look at example 2. Now we will look at example 2 with variables. Discuss the questions with your partner. So what does the model represent in words? So in words, this model represents A plus A plus B plus B, or we could simply say 2 A's plus 2B. What does 2A mean? 2A means there are 2 A's or 2 times A. How many A's are in the model? There's 2. How many B's are in the model? There's 2. What expression could we write to represent this model? So, we could write the expression A plus B plus A plus B, right? Because this is how it would look. Another way we could say it is simply 2 times A plus B. There's 2 of them, so 2A, 2B, so we could factor out that 2 and make it 2 times A plus B. How many A's are in the expression? 2. How many B's? 2. What expression could we write to represent the model? We could write the expression 2A plus 2B. Are the two expressions equivalent? Well, we have 2 times A plus B, and we have 2A plus 2B. Are they equivalent? Meaning, are they the same? Yes, because we saw that simply all they did here was take this 2 that A and B had in common and factored it out. So yes, they're equal. If we multiply 2A plus B, we're simply going to go backwards, and it would be 2 times A and 2 times B, and we'd end up with 2A plus 2B. Okay, example 3. Use GCF and the distributive property to write equivalent expressions. So, first of all, we need to know what the GCF is. If you don't know what that is, then that's a problem, right? Because we need to understand and know what the terms are that they're using in the questions, or we're not going to know how to answer. So, GCF, if you don't remember from 6th grade, means greatest common factor. Okay? So, common means the same. Greatest means the largest. They're looking the largest number that they have the same. So in the case of 3F plus 3G, we notice that we have 3 times F and 3 times G. Now, F and G are different variables. We know they can't combine. They don't have anything in common. They're not like terms. But they both have a 3 in front of it. So 3 would be the greatest common factor. So we could factor out that 3, and it would be F plus G in the middle. Okay? What is the greatest common factor for problem 1? 3. Okay? What is the question asking us to do? To factor out the GCF. Factor out the greatest common factor. How would problem 1 look if we expanded each term? Well, we'd have we would have 3 F's and 3 G's. Now we could do a factor tree. The factor tree is when you look at multiples, right, to see what creates that number. So in this case, we have 3 times F, and we have 3 times G. These are the factors that make up 3F and 3G. When we multiply those two numbers together, we get the original number. So 3 times F are the factors for 3F, 3 times G are the factors for 3G. Now, F and G, like I just said, are different things, but they both have 3 in common. So the greatest common factor would be 3. How can we use the GCF to rewrite this expression? We need to rewrite the expression as an equivalent expression in factored form, which means the expression is written as the product of factors. The number outside the parentheses is the GCF, or greatest common factor. Okay, so all this means is, how can we use the greatest common factor? Well, once you find the greatest common factor for each term, you can factor it out and rewrite it as an equivalent expression, right? That's all that's saying. And the number that you factor out is the number that goes on the outside of the parentheses, and the terms that are left over stay inside the parentheses. So number 2, we have 6x plus 9y. So once again, we're looking for the greatest common factor. Now we know that x and y are different variables, so you can't combine those, right? So we're looking at the 6 and the 9. So we want to make factor trees. So for 6x, we have 6x. For 9y, we have 9y. And we're looking for what multiplied together gives us those. Well, the first one's going to be 6 times x, and the second one's going to be 9 times y. All right, so we know the x and the y just don't do anything because we can't combine them. So the 6 and the 9. 6 is made up of 2 times 3. Those are the factors of 6. 9, we know, is 3 times 3. Okay, so now we see what is the largest number that they both have in common. Well, if we look at this, the 9 doesn't have any 2s, so they don't have that in common, but 6 has a 3, and so does y. So the GCF, or the greatest common factor, is going to equal 3. Okay? So remember from our explanation here that whatever our greatest common factor is goes outside the parentheses. So when we're writing this out, 3 is our greatest common factor. It's going to go on the outside of the parentheses. Everything that stays inside the parentheses is the leftover. Okay? So what times 3 gives me 6x? Well, that's 2x. The x, let me highlight this, the x can't combine with the y, right? So they don't have anything in common. And the 2, 9 didn't have any 2s. So the 2 and that x are the leftovers that stay in the parentheses. Okay? Now let's look at the 9y. What times 3 gives us 9y? Well, 3 times 3 gives us 9. And we need that y, so it's going to be 3y. And once again, if you notice in our factor trees, we have a y and we have a 3. The parts that are left over are what stay in the parentheses. Okay? And you know that you did it right, or you can check to see if you did it right, because if you use the distributive property and multiply it out, you can check your answer and see if you get an equivalent expression or something that's the same as what we started with. 3 times 2x is 6x, and 3 times 3y is 9y. So yeah, we get 6x plus 9y, which is what we started with. So yes, we know we did it correctly. So anytime you factor something out, go ahead and use the distributive property and multiply it back in to check your answer and see if you got what you started with. If you did, you did it right. If you didn't, something happened and it's wrong. Okay, so what is the question asking us to do? The question is asking us to factor out the greatest common factor. How would problem 2 look if we expanded each term? Well, if we expanded each term, we'd have, let's see, 2 times 3 times x for 6x, right? We got that from our factor tree, plus the terms for 9y, the factors for 9y, which is 3 times y. And if the dots are confusing you, I'll go ahead and use parentheses. Maybe that'll make it a little clearer. What is the greatest common factor in problem 2? We determined that it was 3. How can we use the GCF to rewrite this problem? Well, the GCF goes, oops. Hopefully you guys can read my chicken scratch. The GCF goes on the outside of the parentheses. And the uncommon factors, or the leftovers, right, as I was calling them, stay inside the parentheses. Whatever you have left over stays inside from your factor tree. So let's take a look at another example. We have example 3. Example 3 is 3c plus 11c. All right, so in this case, we have 3 and 11. And you're probably going, okay, they don't have anything in common because 3 is only 1 times 3 and 11 is only 1 times 11, right? They're both prime numbers. So there is no greatest common factor. But there is a greatest common factor. So let's take a look at our two trees. We have 3c and we have 11c. We know that 3c is 3 times c and 11c is 11 times c, right? Those are the factors for each of them. Okay, well, the 3 and the 11, yeah, they don't have anything in common, but both of them have c in common. So remember, variables are just mystery numbers. They're numbers, just mystery numbers. But we treat them as numbers. So c, yeah, that's their greatest common factor. That's what they have in common. So in this case, we would factor out AC because the greatest common factor is C. So we're going to factor out that C, and whatever's left over stays in the parentheses. So in this case, the 3 is left over and the 11. Now we could use the distributive property and multiply it back out to see if we did the right thing. So 3 times C is 3C. Yep, that works. And 11 times C is 11C. So yes, we get what we originally started with when we use the distributive property and multiply that C through. So we did it correctly. C times 3 plus 11. So is there a greatest common factor in problem C? Yes. Or in problem 3? Yes, it's C. Rewrite the expression using the distributive property. Well, we already did that up here, right? It's going to be C times 3 plus 11. That's what we got. All right, now go ahead and pause the video. I want you to try to do 4 on your own. Check your answers with your partner, see if you guys get the same thing, and then resume the video when you're done to see if you did it correctly. Okay, so go ahead and pause the video now. All right, welcome back. Let's see if you got this. So 24b and 8. if I'm doing my factor trees, B is definitely not a common factor because 8 doesn't have one, right? So we have 8 times 1 and 24 times B. Well, 24 can be broken down further. 24 is made up of 2 times 12, 6 times 4, but it's also made up of 3 times 8. So there is your greatest common factor, 8. Okay, now traditionally if we were going to do a regular factor tree, and I'll show you, we would do 2 times 12 because we want to break it down to its smallest factors. 2 times 6, and then 6 is 2 times 3, right? And we can't break down 2 or 3 anymore, so we would be done. And then we would look and see, okay, we have all these 2's in common, and 2 times 2 times 2 is 8. So 8, and then you have 8 in the other one. For the purposes of this, we're not practicing factor trees in this lesson. We're just trying to get the greatest common factors. So I would just stick with this. Okay, you know you're looking for a number that they both have in common. So in this case, 8's the number they both have in common, so I can factor it out. 8 times 3b, the leftovers, remember we're looking for the leftovers, is what stays in the parentheses. So plus 1, right? Because that was the leftovers for the 8. And if we multiplied that back out, 8 times 3b would be 24b, and 8 times 1 would be 8. We would get the same thing we started with. All right, explain how you used the GCF, the distributive property, to rewrite the expressions. So the GCF is 8. So I wrote the 8 on the outside of the parentheses, and the leftover factors, 3b plus 1, on the inside of the parentheses. Why is there a 1 in the parentheses? Because that was the leftover factor, right? From the 8, right here. Okay. How is this related to the first two examples? It's related because we factored out the greatest common factor, right? So moving on. Now we have exercises. So we have exercise 1, apply the distributive property to write equivalent expressions. So now this is just practice. I'll do the first couple. I'm going to look at 7x and 7y. So 7x and 7y. Okay, what are my factors? Well, this one's 7 times x and this one is 7 times y. X and y are different terms, so they cannot be combined. But we have this 7 and this 7 in common, so my GCF is going to equal 7, and that means the GCF, remember, goes outside the parentheses, and your leftovers go on the inside. So x plus y stays on the inside. If you multiply it out, 7 times x is 7x, 7 times y is 7y, and you get what you started with. Okay, for problem B, we have 15g and 20h. So my factors for 15g are going to be 15 times g and 20 times h. G and h, different variables, so they're unlike terms. You can't combine them, so they don't have them in common. They're going to be leftovers. And then 15 and 20. Well, I know 15 is 3 times 5, and 20 is 4 times 5. Remember, I'm choosing those numbers. Well, 15, it's 3 and 5. That's all you can choose. 20, you could do 2 and 10, but I know that 3 and 5 are not 2 or 10, right? But if I do 4 and 5, look at this. They both have 5 in common. So that's going to be my greatest common factor. So greatest common factor equals 5. So in this case, 5 will be on the outside of the parentheses, and the leftovers will be inside. So here are my leftovers. I have the 3G and the 4H. So 3G will be leftovers for the first term, and 4H will be leftovers for the second term. If you multiply that out, you get 5 times 3G, which is 15G, and then 5 times 4H, which is 20H. You get what you started with. We did it correctly. Go ahead and pause the video. Do the C through H, and then restart the video when you're ready to see if you got the correct answers. Go ahead and pause the video now. All right, welcome back. So here are the answers for C through H. C is going to be 6 times 3m plus 7n. D is going to be 3 times 10a plus 13b. E is going to be F times 11 plus 15. F is going to equal H times 18 plus 13. G is going to equal 11 times 5m plus 1. And H is going to be 7 times 1 plus 8y. All right, number 2, evaluate each of the expressions below. 6x plus 21y and 3 times 2x plus 7y. For x is 3 and y is 4. So these are equivalent expressions. One just, they factored out the greatest common factor, right, which is the 3 on the outside of the parentheses times 2x plus 7y. So they're the same thing. They just want you to practice solving when you have values for x and y so that you can see it does equal the same thing. So let's go ahead and do the first one. I'm going to split this section in half. On this side, I'll do the 6x plus 21y. On this side, I'll do the 3 times 2x plus 7y. All right, so x is 3, y is 4. So wherever there's an x, I'm going to put a 3. Wherever there's a y, I'm going to put a 4. So the first one's going to be 6 times 3 plus 21 times 4. That's going to give us 18 plus 84, which altogether equals 102. Now on the other side, wherever there's an x, I'm going to put a 3. So this is going to be 2 times 3 plus 7 times 4. So 2 times 3 is 6, 7 times 4 is 28. So that will equal 3 times 34, which also equals 102. So as you can see, they're equivalent. Go ahead and do B and C. Pause the video, do B and C, and then restart the video when you're ready to check and see if you got the correct answers. Pause the video now. All right, welcome back. So I'm going to go ahead and do B and C so you can see if you did them correctly. I'm first dividing the sections in 2 for both sides. So for the first side, we have 5G plus 7G, which is going to give us 5 times 6 plus 7 times 6, which is 30 plus 42, which equals 72. On the other side, we're going to have G times 5 plus 7, which gives us 6 times 5 plus 7, which is 6 times 12, which also equals 72. For C, I'm going to split down the middle. On this side, we're going to have the 14x plus 2. X now is 10. So this is going to be 14 times 10 plus 2, which is 140 plus 2, which equals 142. Okay. On the other side, I'm going to have the 2 times 7x plus 1. That's going to equal 7. 2 times 7 times 10 plus 1, which is 2 times 70 plus 1, which equals 2 times 71, which also equals 142. So once again, we get 142 on each side. D, explain any patterns that you noticed in results A through C. So the pattern that you were supposed to notice is that the two expressions are equivalent. And remember, equivalent means equal. E, what would happen if other values are given for the variables? Okay, so what they're saying is if you actually got a number for the variables or they changed them, what would happen? And the important thing you need to know is because the two expressions are equivalent or equal to each other, it doesn't matter what the variable or the value for the variables would be. It would always be the same. They would always equal. Okay? So because the two expressions are equivalent, they equal the same number no matter what the value is chosen for the variable. How can you use your knowledge of the greatest common factor and the distributive property to write equivalent expressions? Okay, oops, my screen moved. We can use our knowledge of the greatest common factor and the distributive property to change expressions from standard form and factored form. So before the expression is factored, before you factor out the greatest common factor and write it with the parentheses, before that it's called standard form. So we can use our knowledge of the greatest common factor and the distributive property to write expressions from standard form and make them into factored form. So now we have find the missing values that make the two expressions equivalent. So before you had to come up with what would the factored form be. Now they give you the leftovers and the parentheses and you just have to try to figure out what the greatest common factor are, or the greatest common factor is. So for the first one, it would be 4. How did I get that? Well, I have 4x and I have 12y. Okay, I know the x and y are going to be leftovers, so we're just left with the 4 and the 12. Well, the greatest common factor they have is, I know 4 goes into 12 3 times. And 1 times 4 are factors of 4. And look at this, 4 is the largest number. So the other thing you could do is, you could look at what is left over and go backwards. What times x is going to give me 4x? 4. And what times 3y is going to give me 12y? 4. So you can either work your way backwards that way and look at the standard form to see what the missing number is, or you can look at the factors. Go ahead and try to find the missing greatest common factor for the next 4 problems. Pause the video, and then when you're ready to check your answers, go ahead and resume the video. Pause now. Okay, welcome back. So you should have gotten 5, 9, 8, and 100. All right, explain how you determine the missing number. Well, that's up to you to figure out or to explain how you figured it out. Did you look at the greatest common factors for each of the numbers in the standard form? Did you work your way backwards and go, okay, what number times the leftovers gives you the standard form? However you did it, go ahead and explain in the space below. So moving on, you have your problem set. That's going to be your homework for tonight. Go ahead and do that. And remember, if you have any questions, if you're confused about anything, if you need more help, whatever the case may be, remember you can always ask me during class or make an appointment with me for office hours, during my office hours. And I hope you guys have a great day. Bye.